Hello, everyone. Today is 5th May 2024. Welcome to Karmada community meeting. This meeting is recorded and will be uploaded to YouTube. So let's get started. Uh, Today I did Tia, right?
That's right.
And yeah. So you can go ahead.
Yeah, sure. So, Mihas, feel free to jump in whenever. Um, but yeah, I guess we are currently working on deploying like Flink clusters using, using Karmada for Flink clusters. And I don't know, should I like kind of go through the use case, or should I just go through the problem that we're facing?
I want first. I want to know your use case, especially how you use Think for now, and what do you want from Kamada, so we can figure out the gap as well as the possible the solutions.
Mm. So, Aditya, I can maybe go over the use case, and
Yeah,
then
sounds good.
how about you go over the question that you added?
Okay, yeah.
Um, so, hi, I'm Mihash, working with Aditya on this as well.
Hmm.
And essentially, our use case is, like Aditya said, for deploying Flink applications through the use of a CRD called Flink deployment. So what we're interested in using Karmada for is for cluster DR failover, as well as application level failover. Um, so we kind of make a distinction between the two. Um, Obviously, we want to provide our users kind of the confidence that if their cluster where their application is running in goes down, that application will be rescheduled in another cluster where there are available resources and the API control plane is up and running. Um, so we've tested this use case with Karmada already.
Hmm.
We've killed a cluster where we've had a Flink deployment scheduled. And after around 10 minutes, we have to tune the grace period. But that application was failed over to a different cluster and then spun up. Um, the other issue that we want to kind of handle with Karmada is an application level failover. So there could be cases where a cluster has a couple nodes that go down, but the API server and the Kubernetes control plane are still in a healthy state. In that case, Karmada won't mark that cluster as unhealthy because it's just communicating with the API server to get health metrics back. If the
Yeah.
control plane's working, then everything's okay. But let's say that a couple worker nodes go down, and our Flink deployment or the resources that are scheduled through that Flink deployment go down, and then they're not able to be rescheduled due to lack of resources. Um, we also want to reschedule applications in those cases. And so what we've been doing is we created a custom health interpreter,
Hmm.
which just monitors the health of the Flink deployment.
Hmm.
So it kind of just parses the Flink deployment status and then
Hmm.
determines whether it's in an unhealthy state just based off of its life cycle. Um, and so we've tested that as well. That seems to work. And so I think the problem that we were interested in talking about, maybe Aditya, you can take over.
Yeah, so like the one of the problems that we wanted to talk about is when, let's say there's like a network failure that causes a disconnect between the Karmada control plane and the member plane, the member cluster control plane. There could be this situation that arises where the member cluster is processing its own Flink job. Um, um, but also since the Karmada sees this disconnect, it's going to try to migrate the job that was on that member cluster. And then that's going to cause the same Flink job running in another member cluster and causing this duplicate processing that we want to avoid. Like Flink by itself handles like one of the support features it supports is exactly once processing. So this case where we have um, two different clusters um, performing the same processing on um, is something that we just want to avoid. So I'm not sure if anything, if Karmada like supports this out of like outside the box, but yeah, that's what we want to learn more about.
Yeah, I guess to give more background specifically on the use case, like whenever we deploy a Flink deployment to a cluster, there are a couple custom resource dependencies that we also have to install. That would include like a data source object, which is just like we primarily use Kafka, but essentially just something that's feeding data into the application, the streaming application. That streaming application will be processing that data. And then we've enabled checkpointing. So essentially, whenever that application finishes processing a certain subsection of data, and after it's made sure that it's committed that processed data to a sink, where that data will be stored, then it'll checkpoint, meaning that it will essentially save the state of the application, as well as the state of the Kafka source where that data is getting read from. So all of that information is going to be stored in an external database.
Mm-hmm.
And when an application fails over, ideally, our new application would essentially just start from the latest checkpoint that it can find in that shared database. But what we're worried about is, let's say you have this network partition like Aditya was mentioning, and Karmada senses that it can no longer communicate with the API server of one of the member clusters where a Flink deployment is scheduled. Well, then after, let's say, the 5 minute grace period is up, it'll mark that cluster as unhealthy and attempt to reschedule any resources that are on that cluster, if my understanding is correct. But from the perspective of that member cluster, it's going to be still running all the jobs that are scheduled there, right? Because the nodes are still
Yeah.
running. It's just that it can't communicate with Karmada anymore. And
Yes.
so that Flink deployment job, it's going to be still processing data from the Kafka source. It's going to
Yeah.
be writing those checkpoints to our shared database. And meanwhile, Karmada will schedule a new Flink deployment on a different cluster. And that's something that we want to avoid because in those cases, that Flink deployment that just got scheduled will attempt to read from the latest checkpoint of the shared database, and start processing its own data in its own way. Um, and because we want to guarantee to our customers that the data will only get processed once, we want to avoid that because it's going to be committing that processed data into a shared sink as well. So um, I think that's what we're interested in. Like, is there any ability for Karmada to have like a two-way connection with its member clusters so that if for some reason there is a network partition there, that we can make sure that the applications that have been scheduled by Karmada on that cluster are essentially removed from that cluster before it decides to reschedule somewhere else. And I think the only way that could really happen from my point of view is if there's some sort of agent that's running on one of the members and it's communicating with the Karmada control plane, like having a two-way heartbeat essentially. And if that network partition is there and it still can't connect to Karmada, then it's going to assume that it's going to reschedule those applications and that any applications that have been scheduled by Karmada on that cluster should be taken away. Um, but that's essentially the use case. If you have questions, let me know.
Yeah. I can get it. I think you in the scenario you mentioned that if Karmada control plane cannot talk to the mem cluster API server, it treats the cluster in the unhealthy state and start
Mm,
to fail over the Flink deployments. But at that time, maybe the Flink application is running normal, and I think for this case, the failover shouldn't be shouldn't happen. So I think the application failover might be uh, most um, what
More suitable to
more
that.
suitable to your case. Yeah, uh, as in the application failover, the failover happens exactly as the phase that Kamada can detect failure of the Flink deployment. So
mm. I guess the concern, because I agree, we do think that the application failover is, I think, better for most of our use cases. The issue is if Karmada can't connect to the member cluster's API server, then it won't be able to delete the Flink deployment resource and reschedule it, right?
uh, sorry.
Yeah. It's if the connection is detected, actually Kamada just create another copy of the deployment. It doesn't really delay the running Flink deployment, right? That's the point. I think the current key issue is that the health checking relying on the connection between Kamada control plane and the member cluster API server. It of course the kind of the it's very kind of you know it's not a very advanced disaster detection mechanism. So I think one of the way we can mitigate is that we did detect more detailed status, but that only helps in other cases, the like other type of the disasters. If the connection is if the the connection between command control plane and the member cluster API server is broken, I think it will be hard for the command control plane to kind of mitigate. Anyway, there are kind of some other mixed disasters. For example, the connection disconnected, but also there are some error on the in the member cluster. So maybe we still want Kamada to create another copy of the deployment in a new cluster. But if we can introduce some mechanism for the clusters to communicate with each other, so we might get another way to double check the actual status of different the clusters. That's what I'm thinking about. Yeah, just some quick thoughts.
So I guess Mihash, correct me if I'm wrong, but I think whenever a disconnect happens, we always want to migrate the job. So um,
Um, by disconnect, or we're talking about like the network
yeah,
partition.
the network partition. Yeah.
I think it depends on how we set the grace period. Um, So I forget what the default is. I want to say it's 5 minutes, but um, we don't want to be rescheduling applications unless we're certain that we need to. Like there
Right.
could be cases where there are intermittent network issues, and we want to be resilient to those as well.
Right, of course.
Um, but yeah, if there's a network failure that's been going on for longer than the grace period, then yes, we do want to reschedule those applications. Um, I think the issue which Kevin mentioned, is just that there's no way for Karmada to currently do that if the connection is broken. Um, so you would need some sort of way for either clusters to communicate with one another, or at least for the member cluster, to have some sort of like heartbeat check that, okay, am I still connected with Karmada? If I'm not, then somehow can I deschedule these applications?
Right.
Do
Yeah.
you think we can extend the cluster remedy for this use case? I see it's like introduced in 1.9, the cluster remedy. Do you think we can extend that for this use
Uh,
case? I post a link in the Zoom chat.
okay.
Yes, um, so you know, what's your question? Oh,
Oh, I mean, is that possible to use the cluster remedy, like to extend that for Flink use case? So my understanding is like in the cluster remedy, you have a fine granularity to detect if the cluster is in a healthy state, or right. Not only detect the API server, is also track the other components. So it's I don't
yeah,
know. I'm just asking if that is possible.
yeah, it's possible. For the cluster status based remedy is a part of the feature uh, we call the cluster problem detector, and but it's still in work in progress. Mm, with the idea is that we want a component that can um, detect the cluster healthy status and report to Karmada control plane, and after that, Karmada can take actions on like the failover. So since the cluster problem detector uh, is uh, is intended running in the memory cluster, so it can get a more detailed information of the cluster instead of just uh, current with a command control plane just the text heartbeat with the memory cluster.
Yeah, I would like to add that. So we have a kind of I think we have a common understanding that judging cluster status based on the connection between command control plane and a member cluster API server is kind of very rough way of doing that, right? Especially in some cases, for example, the certificate between the connection for connecting the member cluster API server might be out of date, and then the connection broken, but the underlying cluster is actually running. So one of the ways that we split different, detailed issues between the exact cluster status. So if we can detect in the situation when a cluster is really down before we trigger migration, and I think that should be helpful. Um, yeah, so also and similar mechanism in the Kubernetes for the node status checking is that when the node lost the connection, I remember it's the node controller will in the early days is the node controller trigger another try to query from through the underlying um, infrastructure APIs to check the virtual machine status. Maybe we can, add also a double check in that similar way of checking, for example, to identify whether it's only the API server lost the connection, or the cluster have really some of the problems.
In the case if certificate is expired, will Karmada reschedule a deployment in a different cluster?
So currently, the Karmada should already implemented the automatic certificate rotation. Yeah, just some of the corner case, for example, the rotation uh, cycle broken might be, but theoretically, I think it won't happen.
Okay. So in the case of split brain, right, that the problem that we just described, is the recommendation to actually look for an application checks, right, that would prevent having two instances of application running? Is that what is current recommendation? So I guess from in Flink use case, right, if let's say Karmada reschedules an application in a different cluster, Flink can detect that there is already a previous instance running, right, and then prevent to start another instance. Is that the recommendation?
Yeah, I'm also thinking about that way. Actually, I would say that mechanism definitely, fixes the issue, because if there's already one of the instance writing the data, and you have another kind of plugin or other agent to check that status, it's kind of you are actually checking through the path that the actual Flink process will do, right? So that definitely helps, I think. The only thing I'm thinking about is that I'm not sure if it's difficult to develop that mechanism, or kind of where we are right now, if we want to implement this in that way.
Eugene, could you repeat the mechanism? I think I missed it.
So I was thinking, right, if we have a Flink application running right into some data store, or like there is a check that says some logic that says the application is up and running, right? Then when, let's say, we have the split brain issue where we lost connectivity, I mean, Karmada control plane lost connectivity with with a workload cluster where Flink application is scheduled currently and tries to reschedule, let's say in another cluster. When Flink application comes up, it does this check, sees that the previous application, like previous instance, is still running and refuses to come up.
Yeah.
I mean, there are like different ways to implement it. It could be some kind of like zookeeper-based leader election or.
Yeah.
Yeah.
Okay.
Yeah, I just come up with one of the idea. If you know, there's some mechanism used among Kubernetes controller instances. When the controller or also the Kubernetes cluster start up, it will try. It's kind of a leader election mechanism. Try to lock one of the config map, I think, and it's kind of to identify which of the pod is kind of active with, and the other is standby. Maybe you can kind of make use of that mechanism for the Flink application between different clusters to distinguish which one is kind of currently connecting to the data, and it's able to write and prevent the others start.
Would you be including some sort of annotation on the job, or some sort of flag to essentially let the application know that it's not meant to be processing data? Because I guess like my question is, if you start up the Flink deployment on a cluster, if it doesn't have an idea that it's not supposed to start processing data, then it's gonna start processing data.
Maybe for example, add an init container. When it fails to become active, it prevents the pod start.
Mm. Yeah,
Right. For example, try
feasible.
access the data, try write data, but you have a mechanism to prevent multiple writing, and then if it fails, it prevents starting. Right.
Yeah. Okay. Yeah, I think that goes back to kind of like the zookeeper idea that Eugene had. Essentially just having some sort of way to have applications sense whether there's another application that's currently running, processing the same data. Yeah, I think that's something to look into.
Okay. Last week I just run a demo of a Flink, and I have some questions here. And th there are two deployment modes supported by the Flink Kubernetes operator, and I wonder which mode do you use, an application mode or the session mode?
Yeah, we only use application mode currently, so it's only going to be Flink deployments.
Okay. Another question, how many replicas of the job manager and the task manager? Since
So
in the demo there's only one job manager and one task manager. So I wondered, usually
yeah,
uh,
so the Flink operator will only create a single deployment, which is just going to be representing the job managers. So the job managers themselves have a replica setting within the Flink deployment CRD, and that's what operator will read and set within the job manager deployment. The operator isn't going to be the one that's actually spinning up the task managers, or I guess it is communicating with job manager, but job manager itself will be spinning up task managers lazily. So whenever it needs work to be processed. So those task manager pods will come up once job manager requires it. Like a rough estimation, you can take a look at the parallelism for the job and divide the parallelism by the number of task manager task slots. So, for instance, if the job has a parallelism of four, but each task manager only has two task slots, then job manager would spin up two task managers.
Okay, got it. Another question, can we observe the state of a job manager and a task manager from the Flink deployment? Uh,
Yes. So you can observe, I know for sure you can observe the job manager status. It has its own separate kind of section. With task manager, I don't believe so, only because job manager is what's like keeping track of the actual Flink state. So whenever operator, like Flink operator is publishing that status, what it's doing is it's communicating with job manager, and job manager is maintaining an internal Flink state for the job that's currently getting run. Um, so there's a separate Flink state diagram that I can point you to. And that's essentially what gets added to the Flink deployment status while the job is running.
yeah, from this the Flink deployment, um, this is the job manager, so we
Yeah.
can get the status from uh, which one
Yeah. So
job manager
there's
deployment state. Is
so
this?
that's going to be the status of the deployment. And
Mhm.
then the job status is what's getting populated via the job manager. So that job status dot state. Um,
This here.
exactly. Yeah.
Yeah. Okay, if the job manager not in the running state, we can think there's something wrong, so we can start to fail over, right?
Yeah. What we decided on doing is we set the health interpreter to take a look at the starting states,
Mm.
only because there are like a certain number of terminal states in like the state transition diagram. And that can either be failed, it can be succeeded, it can be suspended. Regardless, we wanted to differentiate between application level errors that are just due to like code issues that the tenant might have versus the inability for the cluster to schedule the application. And so in cases where the deployment isn't ready and we notice that the job manager or task manager pods are in a pending state, then we notice that the job status is always going to be either created, meaning that the job is created but it's just not able to run yet, or it's reconciling, which it's just a placeholder for an unknown state. So we set the health status of the Flink deployment to unhealthy if it's in one of those states for longer than 60 seconds, because we assume that those two states are meant to be ephemeral. And if they're not ephemeral, then we determine that there's some sort of issue with scheduling the application.
Okay, thanks. I'm asking that because I'm thinking. Uh, Actually, we love to maintain the healthy interpreter in Karmada. So you can see there is already some open source resources in Karmada, like here, custom. Yes, there are already a lot of the third party resources here. So I'm thinking if we can put the Flink deployment here, so that for example, for you don't need to write another interpreter. So
Okay, got it. Is that something that we should work on, or this would be essentially just like a default interpreter, or
yes, exactly. Yeah, that's the default resource interpreter.
okay. Should we create an issue for that then, or
Okay, that's cool. So you might be you are the expert to write the interpreter. Yeah, sure. We can create an issue for that.
okay, sounds good. Um, and I don't want to take over the entire meeting, but Aditya, I think you also had another question specifically about annotations.
Yeah. Um, so yeah, let me know if we're going over, but another thing that we wanted to add was in case a cluster does fail over and like the job gets migrated, is there an annotation that we can add to know that the job got migrated? This is specifically because Flink being a stateful application, we would need to read the latest state to resume the job. So if we know that a cluster, like a job got migrated, and we would need to get the last state that it processed and continue from there, um, like that annotation would tell us to do that particular step so that we can read from the latest checkpoint. As far as I know, I couldn't find any annotation that said that the failover happened and this job got migrated, but I think that's something that's useful to add.
I'm sorry. Are you requesting? Are you request an annotation for Flink?
Uh,
Sorry.
yeah, it's not for Flink, I guess in general. It's more like it's not for Flink only Flink deployment. It's like a more general annotation that says whenever a failover happens for a job that got migrated, we could add an annotation saying, I don't know, like migrated job is like true or something like that. And then that could be helpful for like any job that needs to do something right after it got migrated. In our use case, we would need to read from the latest checkpoint after a job got migrated. So we actually need to patch the spec with a certain field to get the latest checkpoint. So if we know that this annotation exists, then we can always run that patch.
Do you mean we maybe there is a annotation that we can set on the any deployment that let's say the Flink deployment, so that
Yes.
the Flink can get the signal that this is gonna be migrated, so it can prepare something or get ready for the migration, like save something or right.
Exactly. Yeah. So we have Caverno running on each cluster. And so with the help of that type of annotation, Caverno would just act as one of like the mutating webhooks and just alter the Flink deployment resource if that annotation exists in order to set the checkpoint, the state recovery as latest.
But the question is, the annotation is intended set on the deployment. So how since the job is running uh, in the in a container, how can it detect there is an annotation added?
Oh, yeah. So the annotation would be added to the Flink deployment resource. Um, Once Karmada attempts to apply that resource to the member cluster, we have Caverno cluster policies that are installed on that cluster. And so it would mutate that CRD if that annotation exists on it to change some of the Flink configurations that are defined within that Flink deployment. So those configurations would readily be read by the container once it's spun up. But the issue is actually mutating the CRD before it's fully applied to the cluster. And in order to trigger that mutation, we require like an annotation to be set on the Flink deployment.
Yeah, I have a question. How will you distinguish the situation? The one situation is that the Flink deployment is migrated. Another situation is that actually, Flink deployment is created. How do you distinguish these two situations? And I also would like to understand the difference, for your application really doing.
Hmm. So with latest, so there are different types of like state processing settings. Generally, whenever we create a Flink deployment, if we set it to latest, then there's some sort of issue with reading from the database. Is that right, Aditya?
Yeah. So there's like another field that we need to add that basically tells it that it needs to read from this particular checkpoint that we specify in the manifest.
So when we first start the Flink deployment, the state is just supposed to be fresh, and so it's not going to read from any checkpoint when it starts. Whereas if it's starting after it's been failed over, or if you're attempting to start the application from a previous checkpoint, you have to define those things within the Flink deployment, and then set like the recovery to be latest. And so then when the Flink deployment starts up, it'll read from whatever latest checkpoint it can find in the shared database. I guess, was your question specifically about how would you distinguish between, I guess, applications that have been failed over multiple times, or was it simply the difference between starting an application from new versus starting an application from a checkpoint?
Yeah, I'm just thinking about, in other cases or other type of applications, uh, maybe they don't need to distinguish different status. So yeah, I got the requirement. I mean the scenario of the Flink deployment being migrated. Yeah, I'm just thinking about maybe we need to do some further research to design the mechanism. Yeah.
Okay, understood. Would it be easier if we just file another ticket specifically for this use case and maybe we can have a conversation there then?
Yeah. I think that would be very helpful. Yeah.
Okay.
Yep. Sounds good.
So, is there something we gonna talk about?
We had another use case, but Miguel had to drop off, so it will probably happen at the next session.
Sure. Okay. So for the next meeting, we are still not sure if we gonna run the meeting at the for still this time PT 8 a.m. So uh, that's the default time. If we gonna if we change the meeting time, we'll get you updated.
Sounds good.
Thank you very much.
Okay.
Good.
Honkai,
Thank you.
I do have one last question. I'm wondering if you will be attending KubeCon in Hong Kong in the upcoming month. I think it's in August.
Yes, I think I should be there.
Yeah, we have submitted multiple speaking proposals, so we assume we will attend. Yeah.
How
Great,
about
because
you, Mike?
I don't have the budget to. I'm in Canada, so they will not send me from Canada to Hong Kong, but they will try to send someone maybe from China to Hong Kong. Yeah, maybe from
But
QJ. I
but
was just wondering the can we submit a talk together under because you and I are the cluster inventory maintainer, cluster inventory API maintainer.
yeah,
So I think
yes,
you okay. We
yes,
can talk.
yes. That's I'm going to talk with you that we can submit a topic on to the maintainer track. So
Yes, that's what I.
for the budget, I suggest you can try to try with the travel funding.
Yeah, apply for the travel funding. Yeah.
Okay, I'll see. No, my company might not like it because you know they have developers in China. It doesn't make sense to fly someone from Canada over. Like even like there's yeah. Anyways, we can talk offline. But thank you, Kevin. Thank you, Honka.
So great to meet you guys. So see you next time.
Yeah, thank you so much for your help.
Bye. Thank
Thank you so much.
Thank you.
Yeah.
Thank you so much.
See you.
Bye-bye.
See you.
Thank you. Bye.
Bye.